Hello everybody, I'm Debojyoti Karmakar from Computer Vision Lab, American International University, Bangladesh. Today I'm gonna talk about our IEEE Second International Conference on Computing Technology and Information Management paper, which titled Cricket Shot Classification Using Motion Vector. It is a joint work with AZM Etasam Choudhury, MD Saifullah Mia, MD Al Imran, and MD Hafizur Rahman. Cricket, the game of bat and ball. Different technologies are used in cricket for visualization and coaching. Still, satisfactory results for detecting shots are not achieved from recent researches. The problem lies between extraction of features from different video footage from different cameras. Some approaches use field position, camera motion, boundary limit, commentary, and texts. A machine cannot visualize smoothly like human. Several issues involved such as detection of occlusion of human body parts, cricket bat, ball swing, and flow. A machine can detect human body parts from different image. Then articulating body parts may be recognized using different approaches of action model representation. Moving or articulated body parts tracking and estimation of human pose are much difficult to detect from a single video. Semantic analysis for cricket broadcasting video needs large dataset and accuracy level is not satisfactory. Different template-based action classification is used to distinguish between different sports activities. It is hard to classify cricket shot as occlusion of bat as well as the different body parts are not distinguishable. We propose a distinct approach to classify cricket shots using motion vector detection for each of the frame using optical flow and transformation of vectors to angle. We have implemented for only 4 shots in 4 ranges of 360 degree. But using this approach we can classify 8 distinct cricket shots. We have also established the accuracy level for this method. Many researchers have researched on cricket. The Hawkeye is an advanced coaching system for cricket. Rajesh Tandon and Dr. Amitav have proposed semantic analysis of broadcasting video, involve the use of auxiliary cues to detect events. Another shot boundary detection and shot classification based on multi-scale spatiotemporal analysis of color and optical flow features. David Lowe's shift and Timur Kadir's research for feature descriptor helps to identify objects, direction, and with integration with optical flow that can be helpful to detect the bat, ball, and body parts movement direction. Bangping Yo and Li Fifi have researched about modeling mutual context of object and human pose in human-object interaction activities. Machines also have to recognize the human pose by effective learning approach. Ashwini Agrawal and Sumit Biswas have proposed a technique for object detection and motion estimation from MPEG video using background subtraction. Different filter-based tracking like Kalman, KLT, etc. approaches are proposed with several modifications. They have played an important role on the field of object detection, tracking, as well as action recognition. Mubarak Shah, Javed Ahmed, and Michael D. Rodriguez have proposed an action match filter for action recognition, which can distinguish between different sports activities. But these approaches take a large learning set to make template class of the action corresponding to a specific sports activity. A spatial temporal maximum average correlation height filter, regarded as match, is used to recognize action. The filter can capture intra-class variability, synthesizing a action match for a class. cricket shots also related to human pose and action. Here, traditional match filter is generalized to video and vector valued data. We have made the match of video of specific shots. This can be considered as training set. We have made the training set from 6 videos for each shots. Match actually makes the cluster of videos. Now a tested video of shot is correlated with the match. It will get specific frames that matched with the shot. In use, we have used 6 videos to learn every shot and we check it with another video of the corresponding shot. If the matches occurred, it will make another video of specific frames that contain the matched portion only. When the match is greater than a specific threshold value, a cricket shot has been detected. Clustered videos are used to produce match 3D volume. The input video is correlated with the volume. The final output of detected video contains only 7 frames that are matched for the actual cricket action. But testing video had 31 frames. We only select those frames that have matched a particular action and make another video depicting the matched frames only. Now then, we can classify an event. Now we want to classify a cricket shot. At first, we have computed optical flow between 2 consecutive frames. As we know, optical flow is the pattern of apparent motion of objects, surface, and edges in visual sense. Let's say in any video we have 31 frames. We have calculated the flow between frame 1 and 2, then we'll compute 2 and 3 and so on. For this method, we have used modified approach of Lucas-Kanade. In this method, it is specified that displacement of the image contents between nearby instants or frames is small and apparently constant within a neighborhood of points under consideration. Thus, the optical flow can be assumed to hold for all the pixels within a window centered at the specified point. In this way, we have got the motion vectors of all the shots. When we get the vectors, we have taken the magnitudes of the vectors as well. Those vectors have magnitude less than a specified threshold. We do not consider those. The next step is to compute angle of each motion vector. We have used here the basic tan inverse method for complex values as specified here. Vector equals to a plus b of I, angle equals to tan inverse b by a, where a represents real part of complex value and b represents imaginary part of the complex value. All the angles for each vector of each pixel of each frame are clustered at 8 angles range. The classes are -90 to 134, -135 to -179, -44 to 0, -45 to -89, 1 to 45, 46 to 90, 91 to 135, 136 to 180. So that actually contains the whole 360 degree. We have put all the angles of the motion vectors on those correspondent angle class. Next step is to compute the Laplacian of Gaussian. Laplacian of Gaussian is preferred in the scenario as the number of motion vectors are huge in quantity. Based on brightness constancy equation, displacement of each pixel in terms of x, y, and time is calculated, which is represented by u and v and t, where u represents the displacement along the x-axis, V represents the displacement along the y-axis. Horn and Schunk used smoothness constancy equation in order to find out U and V, as in consecutive two frames, the displacement along the x-axis and also along the y-axis will be very nominal, which is close to zero. So that's why the equation formed something like this. Along with finding U and V, we have also computed the weighted optical flow, which is referred to as D, and the formula is given there, where W is a weighted value found from parallel form. After finding the normal flow for each pixel in the entire frame, all of them are clustered into one group. After retrieving all the motion vectors from each frame, we did split into 11 fragments. Each is represented as a histogram that contains only those motion vectors that fall under that particular category. Each histogram is computed and the average of all the motion vectors are calculated. All for each of the angle, we have sum all of the vectors of correspondent angle class. We have taken the class that have maximum either positively or negatively of the total vectors, and this indexed angle class defines a specific shot, where set S contains S1 to S8. Each element represents range of angle single shot. Set V contains V1 to V8. Each element represents summation of the motion vectors related to the angle of ranges. We have done several experiments with our approach. With this approach, we have figured out summation of vectors corresponds to 4 shots. We can detect 8 shots right now with this particular approach. We have tested only on 4 shots. The accuracy level of our tested 4 shots are given on table 3. We have also shown the angles, angle ranges and the vector summations for those shots on table 1. The threshold values are shown in table 2. Now let's say if we run and try to detect flick shot. So if you run this, you see frame by frame all the flows are moving towards the leg side or the flick shot side. Let's take another example, like let's take a cover drive, for example, cover underscore 001, which is this particular file. And now if you save and try to run, now see frame by frame we have computed all the flows are forwarded towards the cover direction. If you have missed, let me rerun again so that you can follow better. Now you see all the flows are forwarding towards the cover direction, so we can distinguish between flick and cover. We have tested on 4 shots. Actually it can be extended to 8 classes again. Now in a different experimental way to represent the outcome, let's see, this is a flick shot we are testing. This is the optical flows that we have computed, and after grouping all the different clusters, now we see this is actually a flick shot that's been played. Let's change it, and so that we can detect something. Let's say cover drive 001, and let's run. So this is a cover drive that's been played by one of the dataset, and actually if you see all the major all the major vectors are pointing to the cover directions. If you add them all and then calculate the most prominent vector, it will be pointing to the cover direction. In this paper, proposed approach for detection of the specific cricket shots included several vision-based tracking approaches and their extensive implementation in a consistent manner. In our approach, we have utilized match filter and correlated the test video with match training set. After getting the maximum correlation threshold, we defined different cricket shots. After analysis of optical flow, we have got the summation of motion vector results corresponds to the angle ranges for each of the angle classes. After getting the maximum correlation threshold, we define different shots. We have stated an accuracy level of our proposed method according to the real-life cricket shots. To the best of our knowledge, these approaches of detection and classifying cricket shots have not been considered for earlier studies. According to the several vision-based approaches and their applications, our approach can be effective as well as efficient. Thank you for listening to me. For any further queries, please do not hesitate to email us. Thank you.